Move on to the next speaker, Professor Reynold Cheng. He's a professor in the Department of Computer Science at Hong Kong U, and he's the Director of Computing and Data Analytics. And he has received many honors, and including Outstanding Young Research Award by Hong Kong U. And so we are very happy to have Professor Cheng here to talk about COVID-19 from very different perspective and more from the big data. Right? Welcome.
Thank you. Thank you, Chair. Good morning. Okay, my name is Reynold Cheng, and I'm from the Department of Computer Science. So today, we are going to talk about some of our ideas about how big data can be used to analyze as well as tackle COVID-19. All right, so I hope you can see my screen. And where do I? All right, so let me take some time to. All right, okay, so here we go. All right, so what is big data? So first of all, let me give you a quick 101 lesson about what is it, okay? So of course, for this topic, okay, I think most of you think about data as something related to medicine, about pharmacy, about patients' records, and so on. In fact, you know, in this world, there's so much data these days, right? Of course, everyone play with WhatsApp, WeChat, Facebook, and so on, okay? And I also treated a lot of messages about this talk to my friends, okay? Document data, reports, papers, of course, okay? Location data, for example, about cases that are confirmed, okay? You want to know what are the locations of the patients, okay, or those who have suspected cases. Octopus data about the check-in and check-out of the passengers from MTR stations, okay? Google data about what kind of informations or people that are looking for, what are the queries, what are the histories of their search, okay? Of course, okay, these days we are locked at our home, so very often we have to watch a lot of video data, okay, and listen to songs, etc. In the end of the day, all these fancy data are what? They're just bits of zeros and ones. They're just binary numbers stored in the computers, laptops, or mobile phones. All right. So what characterizes big data? Okay, in fact, general definitions of big data is characterized by the so-called 3 V's. The first one is the volume, meaning that these data are extremely large. They cannot be just stored in your laptops or computers, but they have to stored in some special places known as data centers. Velocity is another characteristic of big data, in which it means that data are generated at an extremely fast manner. Right? Very huge amounts of data are generated in seconds because of those technologies reported by sensors, reported by thermometers, and different kinds of data could be generated at an extremely fast manner. Another important feature is that data comes in a different form. Right? So we have different kinds of data already in our laptops, like in our Microsoft Word, Excel spreadsheet. Right? But in the talk, I will also talk about some other kinds of data that you may have not thought about before. All right, so what can big data help us? So people are interested in big data because they find that big data has been increasingly useful in different kinds of applications. And together with very new and interesting machine learning or AI algorithms, big data can help us to do predictions, make decisions, find different kinds of relationships about objects, and as well, hopefully, improve our life quality and help us to tackle COVID-19. All right, so just to give you a little bit more information, big data has now played important roles in different sectors such as banking and financial services, manufacturing, healthcare, and public sector. And here in the bottom, okay, I can see that there are a huge number of money, okay, invested in data markets and data technologies. In China, for example, over $1,400 million have been invested in data markets already. And we see that there will be a lot of interest in this area. So one question is, okay, how can we find this data? So very often the data are kept private and companies don't want to share them easily. But recently, there is also a move from different countries and governments in which they also want to make this data public so that researchers or mobile app developers or even casual users can make use of this data to do their analysis and develop their applications. All right, so going back to our talk, how can we tackle COVID-19? So is it possible for us to make use of big data to understand more about this virus so that we can do some more interesting analysis and of course, crucial actions against them? Okay. So I will talk about 3 main ideas in this talk. So the first one is about whether it is possible for us to use big transportation data related to disease transmission. So what do I mean by this? Well, okay, from different discussions this morning and also some of the news we read, okay, we think that possibly there is a trade-off between transportation, health, and economy. So if we look at the thing on this left, on the left side, we see that if we maintain full transportation, okay, you have all the buses and MTRs available, okay, a different kind of transportation vehicles are all open to the public. Maybe the economy impact could be lower, but at the same time, the health risk can be high. On the other extreme of the spectrum, there could be no transportation at all. Let's shut down everything. Well, of course, okay, probably this will create a very big economic impact because we could not have transportation to do any economic activities. But at the same time, the health risk could be lowered. So I think everyone is thinking about the question of how can we have a balance between transportations, economy and health risk, whether these 2 risks can be mitigated and at the same time, okay, you can maintain a certain level of transportation. All right. So to counter this problem, okay, I would like to refer to my recent collaborations with MTR Corporation. So in fact, our collaboration started about 1 year ago in 2018, in which MTR and Hong Kong U signed an MOU on the railway operations of big data analysis. And then starting that time, I have been studying the data logs, especially about how the train moves, what are the movement data, and what kinds of departure and arrival times, all these kinds of statistics. And our goal is to try to see whether it is possible to predict what will happen if there is any accident happening on the platform. What kind of delay will be incurred to the train movement? And because of our efforts, okay, we have recently signed a data agreement with MTRC in which just today, actually, I got the 2 DVD-ROMs of data from MTRC. They are very kind and generous in sharing the data with us about all the train journeys of passengers in January to March of 2020. So this data contains some detailed activities of the passengers, for example, which station they get in and which station they get out. So hopefully we can use this data to try to understand the transportation pattern and whether they have some relationship to the spread of diseases. So we don't have much results because we just get this data this morning. Okay. On the other hand, okay, Professor Hugo Lee, who is also working with me closely on this problem, that have also shared some of his results to us. So in the top of this figure, okay, we see that this is the change of the populations imported to Hong Kong with respect to the time domain, and we can see that okay, the number of passengers expected okay to Hong Kong will drop with time because of the shutdown. Okay, and we also see that okay when MTR stopped, okay, there is a very low export of populations and import of populations as well. Okay. In the figure at the bottom, okay, we can see that okay, what is the relationship between the new cases and also the delay of the illness onset to hospitalization. So we see that in the very beginning today is a very huge delay. So that means that okay, when there is new cases, okay, the public or the government acts quite slowly. But then now okay, we can have a much shorter time for the delay in terms of sending these patients to the hospitals. Okay. And another very important data to us is the distributions of different kinds of buildings in Hong Kong. So as you can see here, okay, we can see that there are a number of different locations such as buildings and restaurants, kindergarten, and so on. So hopefully we can make use of this data together with the transportation of the data, such as the MTR Corporation's data, in order to understand how people move okay, and whether this is related to the transmissions of diseases in Hong Kong. So hopefully we can understand this, and then we can start to do some simulations about whether it is possible to shut down some of the transportation tools in order to mitigate or reduce the risk of disease transportation. Another related research that I also want to share is the visualizations of coronavirus. Now here, okay, I show you this slide. This is actually a very famous dashboard used in Hong Kong and developed by Dr. Winnie Tang, our honorary professor in computer science. So her team, together with the ISRI China, has developed a dashboard which allows the display of the confirmed cases at different places in Hong Kong. And of course, okay, I think another very well-known tool is the dashboard developed by Johns Hopkins University, in which we can see that the total number of confirmed cases as well as the number of populations and the confirmed cases in different countries. And then interestingly, they use these red circles to explain, okay, how dense those confirmed cases are. Okay, and also one observation we find that is, okay, as these red circles grow in size, okay, these red circles start to overlap. So it is quite difficult to see what is the detail, which place has more confirmed cases than the other. Okay? So in response to this problem, okay, recently I have worked with my team, and then we developed something like a heat map, okay, which displays, okay, the density of the confirmed cases in different places. Okay, so for example, in this app that we have recently developed, okay, it shows that with color, which is closer to red, it indicates higher density of confirmed cases. Right? And here we also show the news stream, okay, which can be shown to the user. So one prominent feature of our application is that we can easily zoom into the cities, okay, or even the street levels to view what is the occurrence or the density of these confirmed cases. And doing this zoom in and zoom out, okay, for example, we can zoom back, zoom out, okay, to this scale, okay, requires some very high computational effort, and it is not easy at all. So, and our team has developed so far the fastest zoom in and zoom out real-time technologies in this heat map display. Okay. So generally speaking, the previous slides that I showed about the visualization is rather static. Okay? So that means we can only display the confirmed cases, okay, in dot circles or in this heat map. Okay? However, I'm interested to understand whether it is possible for us to use more dynamic transportation data, such as the MTRC passenger transportation, in order to incorporate into this visualization process. So we call this field visualization data mining, which is actually a kind of data mining process to help users or experts to try to use their eyes to visualize what has happened, and so that they can do something quickly. So in order to do this, I have currently assembled a team with a number of very well-known and good experts from Hong Kong U Engineering, together with Dr. Jingjian Zhao from Architecture, as well as Mr. Prof Cheng from ESR China, and also Dr. Leung Hao Yu from Macau University. Okay, so my second talk the idea is about how to use big graph in our analysis. So you know that actually big graph or networks of entities have existed in increasingly number of applications. And I think for biologists, the protein-protein interaction network, which talk about how protein interacts with each other, okay, is actually commonly used and studied. In fact, recently, okay, we also find that there is some open data set about the connections of different diseases, their strains, cities, and human together in a very complex network of data. So generally, okay, this is called a knowledge graph. Okay, and our next few minutes will be spent on how our current discovery on this knowledge graph may help, okay, in COVID-19 analysis. Okay, so in order to do this, okay, our team have recently developed an interesting technique, which is one of the very pioneering techniques called motif-based analysis. So what is motif? So I think you know what is Lego, right? And this is a nice picture about using Legos to build I think there's a street in Bangkok, okay? And you know, the Lego blocks, okay, are the fundamental blocks, okay, of this model. So in fact, even though this network of COVID-19 is very complex, okay, you see this is a very complex picture here. And in fact, there could be millions of these entities connected to each other. It is very difficult to analyze, even if you have a large amount of data. However, we also know that this graph actually is just composed based on motif, which is analogous to Lego blocks. So in this case, for example, a motif is talking about how the city is connected to string and also to a branch. Okay, so we want to see whether it is possible for us to use this motif to help us to understand about the relationship of this COVID-19 virus with different kinds of objects in this network. So in particular, okay, one of our results, okay, is to try to find the so-called motif path, which is a path connecting, for example, between Hong Kong and different cities in the world. So let me try to explain, okay, what this path we find is about. So here, first of all, in this knowledge graph, we find that there are 3 cities: Hong Kong, Zhongkou in Sweden, and also Kaohsiung in Taiwan. And so we can find, for example, the string, okay, or the samples of virus from Hong Kong, okay, and from different cities as well. Now, interestingly, even though these strings come from different cities, but from the knowledge graph, we find that they all belong to the same branch of COVID-19 called branch 1707. Okay, and this COVID-19, of course, okay, has the host of human. Okay. Another way that we can use motif is to find out some closely related patterns, which we call it clicks. Okay, so we do a simple experiment on 2 data sets. So the first data set is about the about the SARS knowledge graph, and we use this motif virus, which is SARS, okay, connected to the DNA or the genes of protein together with the host. Okay, so this is the results we found. Okay, so what happens is if we use the same motif, okay, on a similar graph, okay, in the COVID-19, we find a very different scenario in which now COVID-19 is connected to the human host with much more protein DNAs. So we still don't know why, okay, and that's why we need to have this forum so that the different kinds of experts can participate in this research. Okay, so our goal finally is to try to see whether we can use this kind of motif techniques for us to find drugs that may be useful to tackle COVID-19. So we have done some preliminary work here, not in the COVID-19 dataset, but in an open dataset in medicine called drug bank. So we have done some interesting observation. First, we find that for the drug called loxapine, okay, there could be different kinds of side effects like obesity and schizophrenia. And in another example, okay, called drug repurposing, we find that for tackling the disease schizophrenia, okay, loxapine, okay, could be 2 drugs that could be used to could be useful for schizophrenia. Okay, so could we use this kind of tools to help us to find drugs for COVID-19 is very interesting research. So here, just let you see our user interface in the design of finding this kind of clicks or graph patterns. So we call this a motif click explorer. So for example, okay, the user could first input the data set such as a drug bank, and then they can also draw the motif by themselves, or we also have a module to compute the motif for them. And after that, okay, in seconds, our software will return the motif clicks. And on the right side, you can see a dashboard which shows different properties of these nooks in this knowledge graph. And we can click on this the properties, and then we can see all these protein nooks, okay, that are related to the same family. Okay, so in order to do this research, I have involved Dr. Raymond Law from our computer science department and Dr. Chen as well, okay, who are experts in bioinformatics, as well as we are doing these collaborations with Dr. Paul Tam from SUSTech. And here is the URL for our system that you can play, okay? So hopefully it doesn't crash. All right. So the last idea that I want to talk about is the big data social analysis. So in this research, we are also interested to know what is the public opinion about COVID-19. In order to do this, first of all, we have to collect big data. Okay, and luckily, with the help of Dr. Richard Xu from the Faculty of Dentistry, we have recently collected about 300,000 microblocks about COVID-19 from January to March 20. So this social data could be very interesting for understanding what is the public opinion about this virus. So, for example, this data contains who are the users, the time as well, and also different kinds of contents. So, first of all, based on this very large volume of data, we have to know what are the classes, whether they belong to news, public responses, sentiment, or about education. And we have only done some preliminary experiments for this. So first of all, we find that the number of posts of this message is a lot of them that happens in January and then drop gradually. Okay? And we can also see that from these messages, what are the number of confirmed cases as well. And we also did a word cloud analysis to find out what are the words or keywords that have been mentioned most by these by the social network users. All right, so I'm still doing some kind of analysis on this, and hopefully we could do a lot more on this very interesting data sources. So, for example, one interesting research is to do event detection. Meaning that if someone find that there is an outbreak at close to his home, then maybe he may want to send out this message in Weibo or Twitter to let other people know. So how can we detect this information quickly? Another important problem, I think, is about the finding of influential user. I think in many research in social networks, people have found that if you are able to find out who are the influential users and send the information to him, then this guy or this gentleman or lady may send out this message very quickly and propagate this message to other people. So if we have some important information that we want people to know, then maybe it is important to find the most influential user to save our time so that we can ask him or her to propagate this message quickly in the social network. And there are many research in social science about sentiment analysis as well, right? So I think this is also very relevant to understand what is the public thought, whether people are very sad now or they are happier now. So we need to see how we can use these messages to help us to understand this. Another problem that I think we should not forget is that in this era in this current period of time, there are a lot of fake messages. Right? So how do you know which message is fake or not? This is a very difficult problem, and I think you cannot just say that I use AI to do this. I think this involves a lot of experts, beyond what computer science to do. Okay, so that comes back to our last slide about what we can do, as a data scientist. I think, honestly, for data scientists, we may not know much about a lot of the details about what other experts can do, but we hope that, with our experts on data science, all the tedious work of doing the programming or analyzing the data, how to pre-process the data in the right format, how to clean them so that you don't have erroneous or fake data is still very important. So we hope that we can develop some good tools to support collaborations around data. Okay, so what I dream of is a very effective, efficient, and scalable platform that allows different kinds of data to be easily deposited into the platform. And also, depending on different experts, they may have different interests on what kind of data that are related to them. So we hope that we can develop new tools to help them to find, select, and filter data. And also, an important thing is how can we organize this data in a systematic way? How do we integrate different kinds of data? For example, how can we integrate MTR data together with the data from Professor Lee? How can we do this data, integrate them in a flawless manner so that we can analyze this data, without any problem? So recently there is another thought in this field called human in the loop. So human in the loop means that we don't really trust all the AI or the computer algorithms because that is too dangerous. And also the expertise, from the real experts is very important. So how can we involve human experts in the process of analyzing the data and make deductions or predictions is very important. And how can we have a good software to integrate human and machines together in order to have a streamless analysis of this data will be our next task. All right. So just some acknowledgements to Professor Lee, of course, for providing some very nice results and idea and insights for this talk. Dr. Leung Hao Yu from Macau University, Dr. Tang Bo from SUSTEC, and Dr. Moret Osani from QCRI. All right. So thank you very much. That's the end of the talk. And I also want to thank my students for their very hard work in helping me to prepare these slides. Thank you very much. Any questions from the audience?
Thank you, Professor Chen. Yeah, there are some questions from the audience. I will pick up a few to ask. And there are a large data sets in mainland and also in the United States. These investigators in Hong Kong can have access to those data sets and utilize the platform you have generated to be more effectively verify or discover new motifs?
Thank you for this very good question. Actually, for us, one of the problems is to get data. As I said before, sometimes the countries or the government want to protect the privacy of the users. Right? So if we just ask them for some very sensitive data, like the patient's records from the US, probably it is very hard. Right? But on the other hand, okay, as I said before in the very beginning, there are also efforts, okay, from governments to release the data, okay, which we call open data for further analysis. In Hong Kong, actually, there is also a movement in releasing this data for, as open data from the government for the different study purposes. But I think whether it is possible to get the data from the government or companies, okay, I think sometimes it depends on trust. Okay, depends on whether they trust that you work with them well or you will protect the data well. And there is also another technology, okay, called anonymization, okay, which is used to help the owner of the data to try to protect the data, to protect the identity of the users, okay, by covering some of the sensitive information, while at the same time not destroying the utility of the data. Yeah, I hope I answered this question well, but I think this is a very important and general questions. Yeah.
Yeah, so one of the sample of accessing large data is the success of mentioned by Professor Ben Collins, that our specialist, his group, and with working with the CDC of mainland and very quickly analyze and predict the pandemic, and that was a very successful collaboration. So I'm very encouraged by the potential synergy among the people who has the tools and versus the people who have the data. So I have another question coming from the audience,
yes,
which is, can the sentiment analyze facilitate mental therapy? And because the suffering of mental stress during the COVID-19 is pretty obvious and serious. And can the data analyze help to release or reduce the mental problem caused by anxiety after quarantine and the lockdown, and there's many other stress as well?
Yeah, I think we could not help to release the mental suffering from the patients, but at least I think the sentiment analysis of these messages can help us to know what is the severity of the problem, right? So whether the people are really, a lot of people are having this kind of problems. And of course, that depends on our understanding of these messages. So right now we are using some natural language processing techniques to understand the sentiments, to extract the most important keywords or terms or the meanings from these messages. And hopefully, okay, by doing this extraction process, we can understand more about what the potential people with mental sufferings have. Okay, so that we could see whether it is possible to analyze and understand, okay, whether this is a very huge problem and all before we can do the next step. Yeah.
Yeah, so I will continue on this discussion, which is if let the people know he's not alone and other people share common problems, mental problems, and that itself is a release. And then is there possibility to establish small groups, subgroups, so people can share and experience and also provide neutral support to enhance the capacity for us to handle this stress. Right?
Yeah. I also recently have research on the social network community analysis. So I guess maybe that is one of the directions, because once we get these messages, in fact, we can also create a social network, okay, to know which users are connected to each other, which users are friends, okay, which are more closely related to each other. And in fact, in the data mining community, there are a lot of algorithms to try to find out and define what is closeness. Okay? And we have several works on this already, which can quickly and effectively find out which are the close circles, which are the communities of people, and especially if there are problematic, there are the problems, these mental issues about the users who are closely related to each other. I hope that, okay, these messages could provide a source of data in which we can create a social network and analyze their community. Yeah.
So the last question, because time limit, the last question will be more close to home. Is there a possibility or plan to build a strong data in the Hong Kong U community among the students, staff, and so we can make Hong Kong U a stronger community by utilizing the power of big data?
Yeah, I think that is a very, very good proposal. Actually, I think different experts in Hong Kong U, I think you have kind of kept different kinds of data by yourself, right? But the data, the one piece of data cannot solve all the problem, right? We probably need to have a larger variety of the data integrated to the same platform. So the slide that I'm talking about is kind of more like a software platform in which we could put different data together and also different tools together. But how can we integrate this data to a very big repository, okay? And how can we choose the appropriate tools for the experts to analyze the data? I think this is a very challenging task. But anyways, I think this is a very important effort. If we can do this and we unite our forces together to build a very big data platform, okay? And we have different design in the platform to hide the complexity of data analysis and programming. I think that will be very worthwhile effort to do.